people, this is Schedulytics and welcome to today's session. In today's brief video, we're taking a look at the assumptions of the multiple linear regression analysis. If you don't know what multiple linear regression analysis is, we encourage you to check through the videos on this platform and see one particular video dubbed multiple linear regression to know all you need to know about multiple linear regression. What is more, if you stay right to the very end of this particular video, you will be able to know how to use STATA to check these 4 assumptions associated with the multiple linear regression analysis. First, the residuals should be normally distributed. In other words, the residual should pass the test of normality. The second assumption is the equal variance assumption, where we expect that our variables should be or should have equal variance. And we can check that using the Bush-Pagan or Cook-Westberg test of the heteroscedasticity test. The third assumption is that the random error term should not correlate with any of the independent variables. And we can check that using the Ramsey reset test. And the reset there is an acronym which stands for Regression Equation Specification Error Test. And finally, there should be no correlation between 2 or more independent variables, or in other words, there should not be multiple linearity, and we can check that using the variance inflation factor. So these are the 4 assumptions which we are going to be checking using the STATA platform. So now let's go to the STATA platform and see how we can check these assumptions. Right here, we are on the STATA platform and we have imported our data. So now you know that a linear regression model requires us to have our outcome variable being one that is linear. So we are going to select weight here, which is a continuous variable, as our outcome variable and see how some other variables predicted. So we are going to say regress. So you can equally say reg. You can pick it or regress. And then we come here and click on it, and then immediately we click on it to be there. So that's the outcome variable. And then after it, we put in the explanatory variables or the independent variables. We want to see how the chart predicts the weights and sex. You know, the sex of the is categorical. So we add I dot. And then we go to the age of the household head. We also have to, as many as you, mother's education and medic. So we mother's education. I think these 3 are okay. Okay, let's add BMI. Okay. Sorry. Let's add BMI and hemoglobin level. All right, so we click on enter, and then within a few minutes, our regression model has run. So now we want to check the random error term to see if the residual. So first of all, we are checking the first assumption, which is that our residual should be normally distributed. So we are going to predict, we name our residual Schedulytics, and then we say give us our residuals. So it has generated that for us. So when you drop down here, you realize that it's called Schedulytics and it's called residual. So this is it. Now we want to see whether our residuals are normally distributed. So based off the value here, it tells us that it is significantly different from a normally distributed data. So this, for example, is not normal. So this has failed the first assumption test. Now we go to the second assumption, which is the equal variance assumption, or the Bush-Pagan Bush-Pagan-Cook-Westberg test of heteroscedasticity. So it's a post-estimation command. So a start heads test. This is the code for checking that particular assumption. So a start heads test. So here we have the Bush-Pagan-Cook-Westberg test for heteroscedasticity, and the null hypothesis is that there's constant variance, and since the p-value is significant here, we reject the null hypothesis and fail to reject the alternative hypothesis that the variants are different. So here too, the equal variance assumption has been violated. Now, the next assumption, which is the third one, the random error term should not correlate with any of the independent variable. We can check that using the OV test, and that is the Ramsey reset test. And here it gives us the Ramsey reset test. Here too is significant. So what it means is that there's misspecification. So the null hypothesis says that the model has no omitted variables. And here we reject that. And so it tells you that the error term correlates with some of the independent variable. Hence that assumption has also been violated. Now the last assumption, which is that there should not be correlation between two or more the independent variable, or there should not be multiple linearity. So we can check that also using the STAT VIF, which is the variance inflation factor. And one thing about that is that none of the VIF or the variance inflation factor should be greater than 10. Whenever you find one that is greater than 10, it tells you that that particular variable correlates with two or more of the independent variable. And as we can see here, none of these values are greater than 10 or greater than 10. So it helps us to see that there is no multiple linearity here. But the first assumption, the second and third have all been violated. So basically, this is how you can use STATA to check the four assumptions that are associated with a multiple linear regression model. If you like content such as this, we encourage you to subscribe to the channel. We encourage you to share our videos with all. Thank you for watching. Until we meet again, it's a bye.
If you are new to the channel, we encourage you to subscribe to the channel and turn on the post notification bell so you are always notified whenever we release a new video.